Hello. Today in my basement workshop I have this Commodore Amiga 2000 personal computer from the late 80s. This is the first Amiga computer which featured such wide modular capabilities, having 5 Zorro bus slots for expansion cards and a CPU expansion slot for CPU upgrades. Standard mainboard features classic Motorola 68K CPU and 1 meg of RAM, if I'm not mistaken. I'm definitely not an Amiga expert. So these machines are becoming increasingly rare and reach quite a high prices on eBay these days. The story of this computer is that my friend bought it from his friend living in Netherlands, and then it was shipped to Poland via the parcel service. Unfortunately, the parcel service mishandled the package, which resulted in partial damage to the machine, and this led to further unfortunate events. From what I was told by the owner of this machine, when it has arrived to Poland, and it was already damaged by the parcel service, some of the cards which were in the Zorro slots popped out of these slots, probably because the package was being thrown around, and were just lying inside in the case. So these cards were probably inserted back in the wrong direction by the person who did not know that this can damage the card. And as there is plus and minus 12 volts on the Zorro bus, when you will insert the card in the wrong direction, Zorro bus does not have any key or a guard preventing inserting the card in the wrong way, then you can probably damage the card, and possibly a mainboard. I don't know, we'll see. So the state of it now is that it's just being totally quiet. It's not running the kickstart. So it's definitely some malfunction here. So I guess I should remove all the cards and everything and basically try to run this system on bare motherboard to see if it's able to run at all. So let's try to take this apart, partially. So screws are already removed. So the case is broken here. And the floppy is missing its cover. So we have this cover, but it's unfortunately also partially broken. This plastic is bent, so we will have to take care of that. And let's see, what do we have here? So there are several cards. So we have this beauty. I think this is called a bridge card. This is basically an XTPC on a card. So we have Intel 8088 here, some amount of RAM, 256 kilobytes, so we have 512 kilobytes of RAM here. What else is there? So there's this card, which I guess is some kind of a RAM card. So it has a Commodore logo. So A2058, Amiga 2000 8 meg RAM board. So what else do we have here? So we have this card, which is yet another RAM expansion card. Zorro card was the previous one. So this is Memory Master version 1.0. It's also only partially populated. Last but not least, we have IDE card. AT-Bus clone version 0.2. Also a Zorro card. And a compact flash drive. Okay, so now let's try to run the system without cards. Oh, I forgot the power cable. So now it 6 the floppy and it runs. We have a kickstart 3.1. So at least the mainboard is still good. Okay, so maybe now let's try to install the cards one by one and see if we'll be able to go anywhere with this. So this is the ID card. And the system is not able to run Kickstart with this card present in the Zorro slot. So unfortunately, I think this card, as it was for a short amount of time being put backwards, unfortunately it can be damaged. So we'll take a look at it later. Now let's try other cards. So now let's try this memory expansion card. Memory Master version 1.0. It's trying, but yeah, but it's still not able to boot, I think. And there is some kind of an error code. Unfortunately, I'm not an Amiga expert, but I guess this is some kind of an error code from the motherboard. And it's still not able to run Kickstart. So unfortunately, this is the second card that I suspect that it was put backwards. So basically, component side facing the left side of the computer, not the right side as it should be. So I guess unfortunately this can damage the card, as there are 12, -12 and +12 volts on the bus. And if they go into the wrong place, yeah, I guess this can damage the card. Let's try this RAM card now. This is a full-size card. It's impossible to put it backwards. So I guess it was not inserted in this way, even for a short time. Yeah, so at least this card is not halting the system. It's not preventing it from running the kickstart. So that's good. So at least this card is not permanently damaged. Okay, so let's try the bridge card. Oh, maybe I will leave this one inside. Okay, so this, I guess this place is better for RAM card, and this slot is for a bridge card. Okay, so this card also is not halting the system, it's not preventing it from running kickstart. So it's probably both these cards are able to pass autoconfig phase, I guess. Zorro autoconfig. So that's good. And now we can try, as I don't have any Amiga boot disks, like diskettes or anything like that, so we can try to use GoTech to boot the system. So now let's try to boot this Amiga from the GoTech drive. So GoTech drive is basically a microcontroller based floppy emulator which reads floppy disk images from a pen drive, which is inserted here. So let's see. So now I have Amiga test kit floppy mounted in GoTech. So we should boot an Amiga test kit. So this is Amiga test program. And let's look at the memory. So we have 3 meg of installed memory. So from what I know, Amiga 2000 has 1 meg of memory soldered on the mainboard. So I guess as we see 3 megs, so 2 megs is probably from the memory extension card. So let's try to remove it. And let's see what we will see then. Okay, so we have 1 meg of memory now. So this is onboard soldered memory on Amiga 2000 mainboard. So this card seems to be okay. We can do one thing more. We can run an actual memory test. From a test kit. So let's run it. So we have 3 megs, test all memory. So from what I know, this test will just run in a loop. So I don't know when this loop will be completed. Let's wait and see what it will show. So we have round 1.4, 1.5. Okay, so I think 2 rounds is enough. So this memory card and onboard memory seems to be good. I don't know anything about this bridge card, but I don't want to load any drivers for this yet. I will assume for now that this card is also okay. So initial assessment of this machine is that we have to probably damaged cards. We'll take a look at them later. We definitely have a problem with this floppy drive. And we have a broken lever here. And also we have, I think we have a problem with this plastic panel in the case. No, this is just broken and it also will need to be fixed. So we have 2 Zorro cards which for a short period of time were inserted in the Zorro slots in the wrong direction. They both seem to be damaged as the computer is not able to boot anymore when one of these cards is inserted in the Zorro slot. As the Zorro bus has this great feature of autoconfig that is automatically detecting a Zorro card, its ID, manufacturer, and giving this card its own I/O space, we can assume that these cards are not able to pass autoconfig and somehow make kickstart hang during initialization procedure. I would like to understand a bit more about the Zorro autoconfig feature to verify if suspected cards are actually passing it or not. Here we can see a fragment of Amiga 2000 schematic sheet for the Zorro bus, focused on the autoconfig circuitry. So Zorro bus has 2 lines related to card autoconfig control. These lines are pins 10 and 11, CFG out and CFG in. CFG in is an active low card input line, and CFG out is an active low card output line, and Zorro slots are daisy chained, CFG out to CFG in. The procedure is simple. When the card sees an active low CFG in signal for its slot, it should assume that the autoconfig procedure for this slot will now begin, and will respond to a bus read request at E8000, allowing computer to read IDs and other card information. After autoconfig procedure is finished, the card will pull CFG out low and will allow the next card to begin its autoconfig phase. When a Zorro-equipped Amiga computer starts up, it first configures a coprocessor slot, from which the line COP-CFG comes to CFG in line of Zorro slot number 1. Until coprocessor card is not configured, it will keep COP-CFG line high, pausing bus autoconfig. Let's assume that we don't have the coprocessor card. In that case, COP-CFG is immediately pulled low by a resistor to ground, and bus autoconfig starts automatically with first Zorro slot. So let's analyze the case when we have cards in slot 2 and 3, and the rest of the slots are empty. Slot 1 gets a CFG in signal immediately after power up, and as there is no card in the slot, CFG out is being immediately pulled low by a resistor network. OR gate gets 2 low states on the input, and its output turns to low. The next slot can begin autoconfig, and here the next OR gate will stay high as long as the card keeps CFG out high. After the card will finish autoconfig, it will pull CFG out low, and the gate output will change to low, allowing next slot to begin. This procedure will continue till the last slot. So in short, to verify if the card passes autoconfig or not, we can choose a slot, put the card in it, and observe second input of OR gate tied to the slot if it will successfully transition from high to low, indicating finished autoconfig for this slot. So let's try to verify the two suspected cards. Let's see if they're actually able to assert CFG out. And let's compare this with a non-good card. So we know that we're looking for a 74 LS32. So I already see 74 LS32. It's here. And according to the schematic, let's use for this test. Let's use slot 2. So this one. So first I will put a non-good card in the slot 2. And I will just connect multimeter to a pin 2 of the 74 LS32. This will be a second OR gate. We will see if this is a second input of the second OR gate, so we will see what logic level is there. With a known good card, I assume that it should assert low very quickly, as the kickstart will auto-configure the card. So I have connected the probe to the pin 2, which is input 2 of a second AND gate, which is tied to slot 2. And there is a known good card in the slot, this is a memory card. So with a known good card, we see 3.4 volts, which transitions to 0.1. Let's see this once again. So, yeah, so we have a 3.4 and then it transitions to 0.1. So I think we can assume that this is high to low transition. And now let's try it with this suspected card. So this is a memory card. So let's see. So we have 3.4. And that's nice, so it seems that it actually passed out a config. Or maybe not. Okay. So it seems like it's transitioning, so it's trying to init the card, I guess, in a loop, but it's not able to. But the card actually seems to be pulling this line down. That's interesting. Let's try the other one. So now I have this controller inserted. Let's see what will happen now. So we have a high state. And it basically stays there. So this one definitely is not able to pass out the config. The CFG out is not being pulled low. Okay. So this memory card, it seems to pull the CFG out low, but for some reason Kickstart is trying to init it over and over again. This one is not pulling CFG out low at all.